All right, so next we move to a very timely topic, AI assisted mapping. Earlier today, our keynote speaker mentioned it in his presentation. So, in user testing of AI assisted mapping tool fAIr by Radim Štampach, Milan Fila, Jan Horak, and Hugo Crotil, participants compared traditional manual mapping in JOSM with building mapping using the AI supported fAIr tool. The results are generally encouraging but nuanced, so listen attentively as our second speaker delves into the answers later.
So, dear ladies and gentlemen, thank you very much for attending. And maybe my name is Radim Štampach, as was said. And maybe you notice that I am from the same country, same university, and even the same department as previous speaker. But the topic is different. So I want to present you our study, user testing of AI-assisted mapping tool fAIr. So, thank you. Next slide, please. So I am quite sure that in this room of this conference, I don't have to explain what humanitarian mapping is, that the humanitarian organization need maps, that there is a lack of quality maps in many parts of the world. So humanitarian mapping exists. It's very useful work, and but very slow. So, of course, many research try to find some possibilities of using artificial intelligence to extract buildings and roads from imagery. And one of these tools is proposed and developed by humanitarian OpenStreetMap team, and it is called AI-assisted mapping tool called fAIr. Next slide, please. So fAIr, probably you already heard about it because mentioned during even main section. And so it's different from other AI similar projects like Rapid Editor because there is no one big AI model for the whole world. And there is no one big data set extracted for the whole world of buildings and roads. But the idea is that user can train their own machine learning model to extract buildings from imagery in selected locality, ideally in their locality. So, next slide, please. So, as I already said, I am from Masaryk University, but I am also part of Missing Maps community Czechia and Slovakia. And we organizing humanitarian mapping in Brno. So this topic is for us, it's not only research, but it's, let's say, our hard topic. So we are in contact with fAIr developers from humanitarian OpenStreetMap team, Omra Najjar, Kshiti Sharma, and Anza Zancheta. And they asked us to provide some user study on fAIr they developed. So we agreed, and the research goal was to compare AI-assisted mapping of buildings with the fAIr tool and the manual mapping of buildings without AI assistance. And we selected JOSM editor with for as a representant of manual editing because JOSM is well known and it also contains many tools and plugins for mapping of buildings. The main work was done during from October to December 2024. I should also note that we tested previous version of fAIr, not nowadays, but version that was actual last year. Next slide, please. So first, we promote our experiments in various groups. University students, Missing Maps community, Czechia and Slovakia, humanitarian OpenStreetMap team, Doctors Without Borders, and etc. First wave, 38 participants expressed interest. Okay, so we organized webinars for them about how to map in JOSM and how to map in fAIr, because there were two main reasons. Sorry. many of potential participants were beginners, and also we didn't want fAIr to be disadvantaged during experiment by using it for the first time, because JOSM was like well known, but fAIr was quite new for most of participants. So we try to do as much as possible to make participants comfortable. So we provide them everything online. Materials were both in English and Czech. We provide offered different time slots for participants from different time zones. But at the end, we had unfortunately only 26 participants that took part in experiments. So we hope for more, but we try to do all we were able to do. Sorry. So from 26 participants, 14 were beginners and 12 of us were experienced. Experience means their history in OpenStreetMap editing contains more than 1,000 of buildings mapped. They were divided into two groups, A and B. Each of groups contains 7 beginners and 6 experienced users. Next slide, please. So we, as localities, we choose 24 different localities. You can see them on a map. 14 of them were easy to map and 10 were complex to map. 10 complex locality to map means locality with high density of buildings and poor imagery quality. We prepared training data and model was trained for each locality. And I have to mention that it was with great help of fAIr developers. And each participant mapped one complex and one easy locality, one in JOSM and one in fAIr. So that we checked that beginners and experienced participants mapped a similar number of easy and complex localities in both editors. Thank you. So every session of our experiment was organized in a similar plan. First, we explain the rules for correctly and incorrectly mapped buildings for fAIr and JOSM. After that, Group A mapped for 35 minutes in fAIr and Group B mapped in JOSM. After a break, they switched. So Group B mapped in fAIr and Group A mapped in JOSM. After the experiment, participants filled the feedback questionnaire. And after that, we downloaded data. Validators checked the map buildings, and of course, results were statistically analyzed. Thank you. So the main part is results. So first, general effectiveness and efficiency of mapping. We can say that in JOSM, mappers mapped with accuracy 86%. It means that 86% of buildings were accurate, and they mapped with speed for more than 4 buildings per minute. In fAIr, the accuracy and speed was much lower. So we can say that in general, mapping in JOSM was significantly more accurate and faster than in fAIr. But the more important and more interesting results we can see when we divide participants into beginners and experienced. So you can see that beginners mapped in similar accuracy and in similar speed in JOSM and fAIr. There are no differences. On the other hand, experienced users mapped much more accurately and much more fast than in JOSM than in fAIr. Well, it's not surprising. Experienced users, experienced OpenStreetMap mappers are used to use JOSM editor, so they were fast and accurate in it. Okay. And very important and very interesting and very surprising for us. Beginners were more accurate and more faster in fAIr than experienced contributors. Well, one was the biggest surprise during the results. Next slide, please. So we also analyzed the influence of complexity of locality. So I will describe only fAIr. In mapping in easy localities were more accurate and faster than in complex localities. Well, nothing surprise, of course. But more interesting again when we divide beginners and experienced. In case of experienced, well, nothing surprising. They were more accurate and more faster than in easy localities than in complex localities. But beginners were, yes, they were more accurate in easy localities, but very surprisingly, they mapped faster in complex localities. Okay, very interesting and very important. It means beginners are faster but less accurate in complex localities. Faster and less accurate. Well, this is interesting and this is not good news for data quality. For me as a validator, I'm also validator of data. It is the very bad scenario. Plenty of less quality data. So thank you. Next slide, please. So here you can see one example of comparison of FAIR data in green and JOSM data in blue in the same locality. Next slide, please. We can say that in JOSM participants map building after building. Okay, that's a usual scenario. In FAIR, participants selected only those buildings for which the AI model generated a high quality outline. And we can say, yes, that's fine, because it means they understood the procedure of AI assisted mapping well. Mapped only when in case the data offered are fine. In fact, in FAIR, we found that only mostly buildings with simple shape were mapped. Buildings with more complex shape were not mapped. Probably it means, and we agreed, it agreed with questionnaire results, FAIR failed to create good footprints for complex buildings. Well, about errors very shortly, the most usual errors in FAIR, two types. More buildings were mistakenly combined into single outline, and the mapped outline does not match the actual outline of the complex building. So yes, these are the, let's say, the most important problems of artificial intelligence in FAIR. However, we can say that human mappers in JOSM also made similar errors. So we cannot blame artificial intelligence. Artificial intelligence has the same problems as mappers, human mappers in complex areas. Thank you. So only shortly about questionnaires, the most important or most interesting opinions of participants. Their opinion was FAIR wasn't a preferred tool for mapping, but however, participants would return to it in a new version of FAIR. They thought that FAIR is suitable for beginners. On the other hand, JOSM is a more complex tool for precise mapping. So, surprising, interestingly, participants suggested combining both tools. Faster work with FAIR would be complemented with detailed editing in JOSM. Next slide, please. So our results were published in as a public scientific report. You can download it there, or the link is in abstract. So, but only shortly. The main summary. FAIR is beginner-friendly tool. Beginners have similar results in FAIR as experienced contributors, sometimes even better. Users appreciated the simple interface of FAIR, and FAIR is suitable for quick mapping of simple features. On the other hand, FAIR didn't offer proper outlines for buildings with complex shapes, and these problems were greater in complex localities with high density of buildings. Participants suggested combining both tools, starting with FAIR and refining the quality in JOSM. And, maybe very important, participants believe that FAIR has the potential to improve the mapping process and could be helpful if key problems will be addressed. Next slide, please. For the future, 3 points for future. Maybe one quick idea. JOSM, in fact, was very hard competitor for FAIR because JOSM include advanced tools for mapping buildings. It is possible that in case of mapping roads or other features for which tools are not adapted, maybe that tool for AI system mapping would be superior than manual mapping. Very important point is number 2. The fAIr has new version from this year, so it means that the new version from 2025 offer new types of models. You can hear them. You can see here that there are new types of models, more modern. So probably there will be better predictions of outlines. So it would be fine to test the new version similarly. And the third point, we surely will promote fAIr. For example, we plan some special mappathon in Brno that will be attended mostly by IT experts, and we are quite sure that they will be interested in mapping using artificial intelligence and the possibility to train our model. Next slide, please. Last slide. We want to thanks to many sites. We want to thanks to fAIr developers, Omran Najjar, Chiti Sharma, Anna Zancheta, because for their hard work, because without them, there will be no fAIr and there will be nothing to test. And we want to also to thanks to volunteers of the humanitarian mapping community Missing Maps Czechia and Slovakia, to our community who made our large part of the experiments of participants. Sorry. And also we want to also thanks to other participants in the experiment. Next slide, please. And also we want to thank you for attending and listening this presentation. So here you can see some contacts for us, and I'm here right now. So if you want to ask anything, you can ask now or later, and I will try to answer as well as I will be possible. Thank you.
Okay, so thank you, Radim. So the floor is now open for questions. There are a few questions here in venue list, but if you would like to ask them personally, you may just raise your hands and then ask them to Radim. Sige, sige. Yes, Oni.
Thank you so much for the study and for presenting the very important details of it. I'm curious about if there are insights from the study conducted with respect to training fAIr for it to deal better with more complex shapes and so for it to also generate more accurate results with respect to mapping complex structures.
Well, thank you. Well, this is a very good, important question. As was said during the presentation, before experiment, we had to train localities, prepare training data, and also train model and fine tuning them before the experiment, because well, it's training. Creating training data and training model is quite time consuming, so we wasn't able to make it as a part of experiment, because the training of this takes let's say some days even, so it wasn't possible to analyze how beginners are able to train models. I think yes, it's quite important to that the first thing you have to train before using fAIr is to train how to train your model and how to prepare your data. I think everyone can learn it in a few hours how to train it, and after that you have to spend some days to prepare data and train your models. So it is important to know that mapping with fAIr, it's not only about starting tool and clicking yes. Somebody has prepared data and train the model for you. Yes.
Yes.
So I feel like we're seeing a lot of movement from AI assisted kind of tools in general, from this machine learning or image recognition or deep learning approach to also supplementing sort of natural language context. So do you know if for the future of fAIr there will be a way to integrate natural language and natural language information retrieval with the image recognition model. Like the user can type in, "Oh, I see XYZ," and then some LLM can take, the image recognition and the context, and then use that to fine tune and solve for, like, let's say, the combination or looping together of buildings.
Thank you for a very interesting and also very complex question. Well, I have to note that I'm not a fair developer, and even I am not a machine learning developer. But these are very important questions for developers of FAIR, and I know that, for example, Omran Najjar is here on a conference, so probably it is the best question for him. I don't see here in this room, sorry. But yes, I think that there are plenty of ways how artificial intelligence and various types of machine learning can be used for mapping. And I think that the main problem is the capacity of developers, because I think, I'm not sure, but I think that FAIR is mostly developed by two people. I don't want to lie, but maybe two people. So probably they have plenty work with. They had plenty work with to publish the new version of FAIR with new types of models, and maybe after it will be tested, and it is testing right now. They are testing it right now. Maybe after that they will know. Okay, next step will be implementing this one, for example. So yes. ChatGPT, learning models, and so on. Everything is possible if you have developers and you have time and capacities.
I just have a quick question around methodology. You said you have one session doing FAIR and then another session doing JOSM, and then you split it up. Because what we do in when we do training for organized mapping, I also do this test for my team. What I have discovered is that if you do two sessions, it tends to the efficiency is always lower when you're on the second session because they're already tired and things like that. So I'm just curious if there's some approach that that disregards some of these factors when you do the.
So did I understand well that in second section the accuracy is lower than efficiency is lower in second section? Okay. It's quite surprising for me, in fact, because in theory, it should work like this, that in first section, people should, let's say, have some training, and in second section, they should be faster because they trained in first section. So this is, let's say, against the theory of user studies, but maybe it's that's right. In fact, I have to admit that we didn't analyze if first sections were or better or worse than second sections. We always divided the participants only to beginners and experienced. So, but we have the data, so maybe we can do it. Sorry.
Or it could also be fatigue, right? Okay. So let me just ask some questions here. Can I ask why you decided not to compare to standard ID editor rather than just JOSM?
Well, when we were choosing what editor will be representing the manual mapping, we used our experience from our mapathons and humanitarian mapping, and we know in our experience that when we train users for OpenStreetMap and for humanitarian mapping, for the first time and for first section, first mapathon, we recommend ID editor to them, but during during their visit of to second mapathon, we try to push them to JOSM editor. Why? Because we know as validators that in JOSM editor you map faster and with higher quality. So yes, if we would compare fAIr with ID editor, I'm quite sure that fAIR would win, because in ID editor, as a validator, I know that there are always plenty problems with quality of data. And so yes, it would be fine for fAIR if I had some plan that fAIR must win. Yes, I would use ID editor, but well, I want to be fair, so we selected harder competitor, uh, harder opponent for fAIR, just Meritor, which allows mapping building much more accurately.
Maybe this will be the final question for this presentation. Did you compare urban and rural areas? The results with mapping with AI usually show more problems in urban high density areas.
Thank you for a very very good question. Yes, uh, in there was a map with selected localities. We, let's say, didn't select these localities. We were offered them or recommended them by fAIR developers, especially by Anna Zancheta, who studied a special study to fAIR locality and problematics between and differences between using fAIR in rural and urban areas. So um, we used her localities because we knew that these localities were hard to map and these localities were easy to map. Yes, rural localities. In fact, it's not about rural urban. It's more about density and non-dense areas. So, as example, if you will map some suburb of some, let's say, western city, you will see very dense urbanization and dense buildings, but they will have probably some only easy, simple outlines, not very complex. So in fact, in these areas, it's urbanization, it's urban area, it's town, it's city, but the type of buildings is quite similar, easy to map as in rural area. So in fact, our study wasn't about rural contra urban areas, because we know that this study already exists from Anna Zancheta. I think it was presented in Nairobi. I am not sure. I think so. So it would be, let's say, we didn't want to make some duplicate study.
All right, this will be final, because we have some time. We have some time. Um, but this can be a quick answer. Isn't it more of a machine learning pattern recognition approach than real artificial intelligence? I think this is with fair.
Oh, if I understood, sorry, if I understood well, the question was that it's not real artificial intelligence, that it's only machine learning. Yes, that's true. I think that many things that we call artificial intelligence, it's only machine learning. So yes, but it's official called AI assisting tool sphere. So probably that's why we called it like this.
Can't be like FML far, right?
Yes, of course, fair. So because AI, it's buzzwords, I think.
All right. Thank you. Thank you very much, Radim. All right.
Thank you.
Thank you.